Have you ever stopped to wonder how your phone running one operating system can just seamlessly talk to a server halfway across the world that's running a totally different one? Well, the answer is this brilliant concept called computer network layering. And honestly, it's the invisible magic holding our entire digital world together. I mean, just think about what's happening right now. The device you're watching this on is communicating with a server that's probably hundreds, if not thousands of miles away. They've got completely different hardware, totally different software, so how in the world do they speak the same language? That is the absolute core challenge of networking, and the solution is surprisingly elegant. In the tech world, this puzzle has a name. It's called interoperability. How do you create a universal language for all these different devices without forcing every single manufacturer to build their hardware and software the exact same way? That's the communication challenge we have to solve. And the solution is an idea that's both incredibly simple and, frankly, brilliant. It's called layering. Instead of trying to solve this giant, tangled mess of a problem all at once, you just break it down into a neat, manageable stack of smaller problems. So, how does this actually work in practice? Let's unpack the genius behind solving really big problems just by breaking them into layers. The key idea here is decomposition. Imagine trying to build a 1,000-piece puzzle by just staring at the whole box. It's totally overwhelming, right? But what do? You find the edge pieces first. Then maybe you work on the little patch of blue sky or the red car. Each layer in networking is just like solving one of those small sections. And once each little part is solved, putting them all together to see the big picture is suddenly easy. Let's just follow the data for a second. The big goal is to get information from this computer over to another one. So we break that journey down. The first task is the physical connection, the actual wires and signals. The next task is managing the addresses. Where is this thing going? Then we need a task to make sure the data actually gets there without any errors. By solving each of these steps one by one and just stacking the solutions, we solve the whole shebang. Now, this layered approach has two huge advantages. First, it's modular. Think about a car. If a tire goes flat, you just fix the tire. You don't have to rebuild the entire engine, right? And that's the second advantage. It's super easy to troubleshoot. If your Wi-Fi isn't working, an engineer can check the physical connection layer without ever worrying about what the application layer is doing. It makes finding and fixing problems incredibly efficient. But how does each layer know what it's supposed to do? Well, they follow a very strict set of rules called protocols. Think of it like a relay race. Each runner knows exactly when to start running, how to grab the baton, and who to pass it to. In networking, one protocol's only job is to handle the destination address, kind of like the street address on a letter. Another protocol's job is to handle the port, which is like the specific apartment number, making sure the data gets to the right application, like your browser or your email client. Okay, so that's the powerful theory of layering, but how is it actually applied out there in the real world? Well, it all comes down to two very famous models that put this whole idea into practice. First up, we've got the OSI reference model. OSI stands for Open Systems Interconnection. The best way to think about this is as the perfect 7-layer blueprint drawn up by theorists. It's the ideal vision for how any network should be built for maximum flexibility and compatibility. This quote really just nails the core idea. The goal was to create a universal guide so that a Windows PC could talk to a Linux machine, or an iPhone could talk to an Android server, without any of them needing to change their fundamental design. It's all about creating a universal translator. But, and this is the big twist, the OSI model is just that, a reference, a beautiful theory. It's a guiding light, not the actual engine. In fact, it was never fully implemented in the real world. So while it's a foundational concept for understanding networking, it is not what's actually powering your connection right now. So what is the model we actually use every single day? That would be the TCP/IP protocol suite. This is the practical, no-nonsense model that was built by engineers in the trenches. It actually came before the OSI model, and it's the one that ended up winning the race to power the entire internet. This comparison really makes the difference crystal clear. On one side, you have the OSI model, born from theory, designed as a reference. And on the other, you've got TCP/IP, born from practice, designed as a working set of tools. It really is the difference between an architect's beautiful blueprint and the actual building itself.
This is the essence of TCP/IP in action. It's a stack of specialists. You have one layer that's the address expert. It only deals with IP addresses. Then the next layer up is the delivery expert. Its job is to make sure all the pieces of your data arrive, and arrive in the right order. Each module does its one job perfectly before passing the baton up or down the stack.
All right, so what are the key things to remember here? First, layering is the elegant solution that lets all our different devices talk to each other. Second, it works by breaking down the huge problem of communication into small, manageable jobs. And finally, while the 7-layer OSI model gave us the beautiful theory, it's the practical 4-layer TCP/IP model that actually gets the work done and powers the internet as we know it. So we're left with this one big thought. Every single thing you do online, every message you send, every video you watch, every search you make, it all relies on this simple foundational idea of layering. It makes you wonder, without this concept, could our hyper-connected digital world even exist at all?